tell me what you find, all right? So let's see what liquid nitrogen looks like. But first of all, you guys have to stay right there, okay? Because this stuff in this dewar, it's very, very dangerous.
Oh.
It's super cold. First of all, I'll tell you how cold it is. How cold does water have to be to freeze? Yes, in the blue jacket.
Very cold.
Very cold. Well, what temperature does it have to be? Yes.
10 below 0?
No, well it freezes, but it will be frozen at that temperature. But what does it have to? What temperature does it have to be for it to freeze? Yes.
About like 30 Fahrenheit.
Whoa, you're very close. Add 2 to that.
40.
Nope.
50.
Add 2.
32.
32 degrees Fahrenheit, and water will turn to ice. This is so cold. It's a liquid, right? But it's so cold, and it is negative 320 degrees Fahrenheit.
Whoa.
That is just about how cold it is in space. So if you were shot up into space and you didn't have a spacesuit on to protect you, not only would you explode and implode because there's no air, and you would, but you would freeze and break into 1,000 pieces. Isn't that crazy? Watch this. Check this out.
Okay, that's
Oh my God.
scary.
This stuff is so cold that it will boil at room temperature. Does anybody know what they use liquid nitrogen for?
Making ice cream.
Making ice cream. Yeah, we make ice cream here at the Science Center with liquid nitrogen.
Yes.
And they make Dippin' Dots with liquid nitrogen. Yep, that's true. You can freeze fish or meat, and it stays fresh longer with liquid nitrogen because it freezes it really fast. Keep your questions, guys. I'm going to go through it really fast. We'll ask at the end. Also, you can use it to, has anybody ever had a wart removed?
Yes.
Yeah. Liquid nitrogen, they use it, they freeze the wart and they knock it off your hand. Now, or your foot, or wherever, your nose, if you're a witch. So anyway, it's so cold. If I put my hand in there, or you shouldn't do that, but if you did, it would, for like 5 seconds, it would freeze your hand so cold that if I took it and slapped it on this table, it would break into 1,000 pieces. And I'll show you with this onion. I'm gonna put that onion in there. I'm gonna put this rubber ducky in there. Right, cool. Let's see what that looks like. And I know I'm going super fast here. So I'm gonna freeze that for a second. Let's see, tell me a little bit about gases. If a gas is warm, what does the air inside do? Yes, you back there. It pops? Well, warm air, what is air made of? It's made of little things called, well, everything's made of molecules, right? Now, warmer molecules or warmer air molecules are gonna move, are they gonna move slow or fast? Fast. They're moving around really fast. So if you heat up a gas, right, the molecules are going to go like this. Let's talk about this balloon. I blew this up earlier. It has my carbon dioxide in it, right? Think about what these molecules are doing inside of this balloon. Yep.
The molecules. Yeah. They're just.
They're moving around, right? And how does this balloon stay blown up? Let's keep it this guy. What are the molecules doing? What's the air doing? It's doing what? You don't know? Well, think about it. It's staying blown up. Why?
Because the helium inside, it takes its shape.
Well, the air is taking its shape, right? There's no helium in there, but it's carbon dioxide. But all those molecules, they're pushing on the walls of the balloon, the inside of the balloon. They're like, hey, I'm going to try to go this. So they're trying to escape. They're trying to get out, right? So they're pushing out, and it stays blown up. But we tied it, right? And it's staying there in there, so it takes the shape, right? But it's going to stay blown up because they're trying to get out, but they're not. What do you think is going to happen if I cool these molecules down? Yes, you.
It's going to pillow up and keep the warm inside.
Say that again?
It's going to keep it. It's going to shrink.
It's going to shrink? That's a really good guess. Why do you think it's going to shrink?
Because I think this is
Why do you think it's going to shrink? Based on what I told you about the molecules when they're warm, if they're moving around really fast, and they're like at the beach in Florida, and they're like, hey, this is great, I can just move around and just be wherever, right? But if it gets really cold, what do you do when you get really cold and you're sitting next to somebody? What do? Just say it.
You freeze, you stay there.
You push together, right? You squish together so you can stay warm. Well, that's what I always think about these little molecules. When I freeze them, they're like, oh my gosh, so they all go really close together. And they become flat. You see that? But now as they go south and they go back to the Floridian beach or wherever they were, they start to move back apart. and they push back out on the inside of that balloon. Isn't that cool?
Very cool.
Yeah.
It's not gonna pop. Okay, try. Cool. Right on, my
Is it still
friends.
cold?
It's not so cold anymore. Now it's right back to about room temperature. Isn't that neato?
Yeah.
Very cool. Awesome.
Very good.
Tell me what you know about when, so right now, this stuff, it's boiling practically in there, right? And when you boil something like water, what comes off of it? Yep. Steam, right? And what is steam? It's a gas or it's water vapor, right? It's a little bit of both, right? Well, that steam or air, when it converts from a liquid to a gas, what's that called? Does anybody know? Yep. Starts with an E and ends with a tongue. Shun.
Evaporation.
Yo, yeah, very good, man. You are Yale bound. Yale bound, my friend. So, where, if I put a little bit of this in this empty Pringle can, right? It's now evaporating, right? That gas is gonna go where? Where's it going? Yep. Yeah, it's going out here, right? It's coming out, right? What do you think would happen if I tried to trap that gas? Yep.
The top thingy will pop up.
Sometimes this thing is so ridiculous. Ah! We need to eat more Pringles around here. Sometimes they have holes in the bottom. Whoa! Let's try that again. Ah! So it pops off, right? Because it's evaporating out of the air. Let's check on our rubber ducky, huh?
Rubber ducky.
I love it.
Rubber ducky. Whoa!
Oh.
That might be really cold. I would put it down. I would probably put that down. There you go. Just let it warm up first. Did it hurt? No, I didn't think so. You're a man. Very cool. So, let me see if I can find my bag of onion here.
Oh.
Watch this. I'm going to show you what happens to your hand. Put it there. I'm sorry.
Uh-oh. Uh-oh.
Open. Hang on 1 second.
Ew.
You is a stinky bag of onions.
Ew.
Oh,
God.
What's that?
no tears involved.
Yeah, no tears here. So, I'm going to put this onion in this bag. We're going to see what happens. So imagine that this onion is your hand. And you put it in there for a long time. Right? Now watch this, guys. This is awesome. Check it out. Have you ever seen a Christmas ornament? That's what your hand would look like. It would freeze and break and be really glassy. Isn't that cool? You want to smell it?
Yeah.
No! I smell from here.
All right, one last thing with the
Okay.
liquid nitrogen before we move on because we need to.
I'm going to heat up some water.
Drink cold.
Watch this.
This is going to be really cool.
You guys laugh like mad scientists.
Yes.
Don't breathe that! I'm kidding.
Isn't that awesome?
That's all I can do. So I just heated that up really fast, right? And it turned into steam or condensation. Very cool. That's liquid nitrogen. Question, yes?
If you found a loved one and picked your hand in there, would it still be cold?
Yes. These just, even though these are like super thermic, whatever, crazy scientist gloves, they are still, I mean, it wouldn't hurt you if it landed on there, but if I put my hand in there like that, eventually, yeah, it's gonna freeze. Any other questions? Yes.
When you were over there
Yes.
and then you laughed,
Yes.
you sound like Cookie Monster.
Great.
Cookie Monster.
Yes.
Is that colder than snow?
Yes. How cold do you think snow is? That's a good question. How cold do you think snow is? Watch this, let's freeze the pipes. How cold do you think snow is? I love it when I put it in the sink.
Yeah.
How cold does it have to be to snow?
Freeze the
This is like really cool art right here. How cold does snow have to be? 32. No. What does ice happen at? 32. So ice, snow is little ice to water crystals, right? Crystallized ice. And it turns in at 32. Cool. So, we need to break up into groups. Now listen guys, I know it's very tempting to come up here and play with this stuff, but if I see you around here, you're gonna go, you're gonna leave, because this is super dangerous, and I'll try to get this out of the way. But I need to break you guys into groups, and the teachers can help me do that. We're gonna then, in a second, we're gonna break up into 3 groups, okay? This first group right here, this is cool, and I'll come over here and help you. What's up, sorry?
I don't think you have any extras.
Are you serious?
Really, no.
Oh, no, there they are.
Freezer.
They're almost melted. That's okay. It's okay. They'll work for us. This right here, I'll stand here. I'll show you what to do. But we'll have one group here. We'll have another group come over here. You're going to experiment with these 3 different types of powders. They're all safe.